Chapter 16, Lecture 2 is going to get more into the mining techniques and maybe what we can do when we run out of all those good ores that we want. Anyway, we do use a variety of non-renewable mineral resources. They come from the crust or the lithosphere, which is the top part of the mantle and into the crust area. We use fossil fuels, coal, oil, natural gas are the main ones that come from there. We use metallic minerals like gold and silver, platinum, all those things, iron, cadmium, lithium, and so on. Non-metallic minerals are things like salts that we use, of course. Ore is deemed anything that's extracted, purified, melted, and made to desired products. Iron is a type of ore. Gold is a type of ore. Keep in mind, when you get gold, it's not always pure gold. There's usually imperfections or impurities with it. So there might be other minerals that are stuck with it. We need to clean that up. We'll talk about that. There's high-grade ore and low-grade ore. High-grade ore is that which is, like in the gold example, it's almost all gold and there's not much extra stuff with it, which is actually called gangue. Low-grade ore would be kind of what we're getting more of now because it's harder to get, and it would be gold with a whole bunch of other mineral impurities with it, so it takes a lot more resources to get it. The USGS, United States Geological Survey, has 4 non-renewable categories. These are a little goofy. First of all, identified resources. We know where they are. We know how much there is there. We kind of know the quality of it. There's reserves. It's there. We are not mining yet, but we know there's reserves there. We know about what the reserves of oil we have in the United States, and coal is in the United States for important commodities. It is profitable to get them. They're easy to get. Undiscovered reserves, there's probably potential supplies out there we don't know about. The whole idea of fracking has really released a lot of those, what was previously deemed undiscovered reserves. Other resources, stuff that we don't know about yet. You need to go to college and figure this stuff out. It's in there. Case study, very important one, U.S. General Mining Law of 1872. It encouraged mineral exploration and mining of hard rock minerals on U.S. public lands. Think about the late 1800s, post-Civil War. We wanted people to move out west. The government said, go, you can buy, you can claim land very cheaply and make as much money off it as you want, because the reality is we needed to build up our economy with things like gold and other minerals. So until 1995, the land could be bought for 1872 prices. That's changed. We'll do a little case study on this in class in a little lab. Companies must pay for cleanup now. The problem is when there's mining, as you will see when we do our little cookie mining lab, it is not easy to do. A couple mining techniques and words that we need to know. Overburden is soil and rock. So as you can see in the picture on the right, this guy right here and here, oftentimes in order to get to this coal, which is what he's digging, he needs to remove this stuff. That's overburden. He needs to get that out first. That leads into net negative energy if it takes too much to get that coal, or it reduces the net energy. Spoils is any waste, and that generally is in piles, and that can contaminate our environment. There's different types of mining. There's open pit mining, which you can see right here. We've got open pit mining here in the quarries of Sussex and even in Waukesha where they got limestone. Strip mining is kind of like here, very similar to contour mining. Contour mining specifically is strip mining on the side of mountains, which is pretty smart to do, obviously, if we need to get the resources, but not good for our environment. Mountaintop removal is terrible. This is common like in West Virginia where they literally remove the entire mountaintop. Dredging could be done in like the ocean or even like in the Great Lakes if it was a will. The ore is what we are after. It's the gold, it's the iron, whatever we are after. In the cookie mining lab, it is the chocolate or the M&M. Gangue is the waste that is attached to the mineral. So if there's gold that has a bunch of other stuff left on it, that is the gangue. Tailings are pilings of waste. So oftentimes when we do gold cyanide heap leaching, what happens is we get the gold, but then all the waste, it might go down a stream, it might contaminate different watersheds, it might contaminate different farmers' fields, whatever the case may be, bad stuff. Smelting is a process that used to be done basically all the way from Pittsburgh over to Chicago through Gary, Indiana, of course. That separates the metal from other ores. You can see the picture on the right here. That's a big smelter where they heat up the ore, and oftentimes they'll skim off the impurities that float to the top and then pour out the pure iron or gold or silver or platinum or whatever the case may be. That produces a phenomenal amount of. Back to the Act of 1977, mining companies, of course, have to restore surface mined areas. The quarry you know as Foxbrook Park was a quarry at one time, and what happened in order that company, what they did to settle their debt, in other words, make it better, was they made it into Foxbrook Quarry, which is awesome. Menominee Quarry, if you've ever been up there, which is in kind of the Sussex Landon / Menominee Falls area, actually was reestablished as part of the reclamation efforts too. The problem is generally it's not easy to clean up, as the lab will prove. A lot of things happen. We have two different ways of mining. There's surface mining and there's subsurface mining. Generally, surface mining is much more drastic on our environment because the reality is we expose all these things which aren't supposed to be exposed, and then it rains out and it goes down and it gets into our river or watershed systems. Subsurface mining is underneath the ground. However, subsurface mining tends to be much more dangerous. Court case study environmental effects of gold mining. Here's just a little example. Gold producers, the big gold producers around the world are South Africa, Australia, United States, and Canada. You can see those poor people in there right now. What they're trying to do is pan for gold. That was very common, of course, back in the gold rush days of the United States. We don't do it that way anymore. It's much more mechanized. But what they do in order to take the gold away from its gangue or its impurities is they add cyanide to it. If you know anything about cyanide, it's a toxin, and that toxin gets into the environment here. There's actually a case study not long ago in Colorado where cyanide actually contributed to watershed contamination in those poor Colorado lakes. So here's the cyanide heap leaching, just a little bit more information about it, and you can see how terribly that is affected. And the United States actually has really good laws on this, but other nations not so much. Extremely toxic to birds and mammals. In 2000, the collapse of a dam retaining a cyanide leach occurred, and that was out in Colorado, and what happened is it had huge impacts on organisms. Just looking at subsurface mining briefly, what happens is we have a main shaft that goes down, and of course, what happens with that main shaft is the people will be dropped down here, and what they can do is go to many different levels. The way coal is particularly, or really anything, even like silver or gold, is it tends to go in these seams. And what they can do is use seismic activity and gauges in order to figure out where those seams are. And the mining will actually follow those seams. That's why if you ever go tour a mine, they go all over the place, not just in one area. And then, of course, we have another shaft right here. It's really dangerous to do a video on that, too. So subsurface mining removes coal and other ores. You can see the vein right here of coal, so they'll follow that with these big machines. It does disturb 1/10 of the land of surface mining, but again, it's real dangerous for people because gases like methane can build up in there, and of course, we have collapses, and we can get subsidence too, where the ground actually collapses and your house ends up in there, or you end up in there. It's much more dangerous than surface mining. So here, definitely harmful environmental effects. It's a major pollutant of water and air. Mining scars the land. We get subsidence. That's the sinking of the land, because what happens is we have those tunnels underneath the land, and boom, it collapses. Mining does oftentimes contain toxins, and the reality is they release stuff in the environment that's really not supposed to be released because we're digging for it. And sometimes those toxins are emitted to the atmosphere. We have an effect on aquatic life, as you can see that lovely picture there. And we have large amounts of solid waste, or gangue, or tailings that is left over. Mineral resources are distributed unevenly. They're not all in the United States. They're not all in Russia. They're all over the place. Most of the non-renewable mineral resources are supplied by the United States, Canada, Russia, South Africa, and Australia. Of course, the latest boom in the United States is the fracking, which is occurring in the oil extraction in North Dakota. We have tar sands in Alberta, Canada. And we'll kind of break down these, get into chapter 17. Should we take resources from public lands? This is a huge thing. Technically, we're not supposed to. About a third of the land in the United States is public. Extractors want that land, and they want it cheap. In 2002, President Bush actually expanded the extraction of mineral, timber, fossil fuels on public land. A real particular case we'll talk about is ANWR, which is the Alaskan National Wildlife Refuge, where we're really not supposed to be drilling, but they're drilling now. They're actually test drilling to see if they can find oil. It's deemed a very big reserve that could actually for us. So supplies of non-renewable mineral resources can be economically depleted. Remember, economically depleted means it costs more money than people get out of it. So why even do it? 80% of the resources used up, that is deemed depleted. Why go after that bottom 20%? Generally with like oil, they'll take 80% out and then leave the rest because it's too expensive. However, as we'll talk about with fracking, fracking is actually increasing that depleted amount a little bit more. Future supply really depends on the actual or potential supply of the mineral, rate at which it's used. So oil, we know we don't have oil forever, maybe a couple hundred more years, if that. We need something else to replace it. When it becomes economically depleted, of course, we could recycle or reuse existing supplies. You can actually recycle oil right now. Why not? Waste less, use less. The big push right now is just to become more eco-friendly and use or waste less, take shorter showers and things like that. Maybe find a substitute or maybe do. Market prices, of course, affect supplies of non-renewable minerals. Subsidies, of course, tax breaks to mining companies keep those mineral prices artificially low. So our tax money actually goes to that. Does this promote economic growth and national security? That's the big question. Scarce investment capital really hinders the development of new supplies of minerals. So in other words, we really like our gold, we really like our silver and so on. Really not putting money into anything else, so why even bother? Which is kind of a bad idea too. Is mining lower grade ores the answer? So in coal, for example, in coal we've got all the easy coal. We've got the anthracite already, which is very high in carbon content, very low in sulfur content. Should we go after the lower grade ores, which is going to cost more money and it's going to add more pollutants into our environment? Factors that limit the mining of lower grade ores, increased cost of mining and processing, lowers the net amount of money you make on it. Availability of fresh water, a lot of people don't realize there's a ton of fresh water that goes into cleaning these ores, cleaning the machines, cooling the machines. That's all fresh water. And of course, the environmental impact we need to weigh. Maybe improve our mining technology, use microorganisms. So maybe instead of using cyanide to get all those impurities off of gold, use some bacteria, genetically modify some bacteria to do it, which they are doing, but it takes a long time. It's a very slow process. What about genetic engineering of the microbes, of course, to make them go to college for it? Figure it out. What about going in the ocean? Should we do some dredging in the ocean? I don't think so. We're already ruining habitat enough and, of course, causing endangerment in there. Deposits of minerals and sediments along the shallow continental shelf near the shorelines, they're there. But should we go after? Maybe hydrothermal vents. We know where those subduction zones occur in the oceans. Maybe there's some mineral deposits in there. We know there are, actually. Should we go after them? Is it worth it? Is it worth the money to get down there? We could get metals from the ocean floor. Manganese nodules, we know there have lots of minerals in them. How does that affect aquatic life? All questions that are out there. How can we decrease our use and waste of mineral resources? We should probably recycle more. Instead of going after new material, virgin material, let's recycle it instead, like aluminum and tin and plastics and things like that. There's actually something called the Pollution and Waste Prevention Program we'll talk about later, where maybe if you throw out X amount of garbage, you get charged for that X amount of garbage. Or if you recycle so much, maybe you get some money back. So you can get maybe $500 back at the end of the year. Your parents would probably be pretty happy about that. Maybe cleaner production. All questions we need to ask before we go after or continue going after these. And maybe we should make some new stuff instead. All right, that's it for chapter 16.